and the freezer is taking heat away, it's going to freeze at 0. If I take it out, and it's at 0 degrees and it's absorbing heat, it's melting. That's the only difference. Okay? So, guys, if I take this right here, my ice is starting at negative 15, and I add heat, the ice is going to heat up until what temperature? What temperature is it going to stop heating up at? Not 10. What temperature does ice melt at? When it's melting, does it change temperature?
No.
No. Okay. That's what we're looking for. So at 0 degrees, the ice is going to stop heating up, and what's it going to do? What's happening when the line flatlines right there? It's melting. So it's melting at 0. When it's done melting, and all the ice is now back to liquid water, what's going to happen to the temperature of the water? It's going to rise. Okay, once everything's a liquid, it's going to rise, and according to the problem, it's going to stop at what temperature? Look at the problem. 10 degrees Celsius. So, we do. We have 25-degree temperature change, but notice, guys, we have energy here, energy there, and energy there. We have 3 different changes we got to worry about. So the first thing first, we have a temperature change right here. Temperature change involves what equation? Right there. Can we figure out how much energy it's going to take to get the ice to 0 degrees? Yes, we can. So let's take a look at it. The energy equals mass times delta T.
So the whole graph thing is unnecessary what you did. Is what you're saying?
What?
Because you ended up at Q equals M multiplied by delta T multiplied by C. You already had that. So the whole graph thing is just, you could just throw that out. Right? No. You need the graph. Well, you need the graph? For what?
I'll show you.
Alright.
When we use this equation, all it's doing is taking care of this part of the graph. All we're doing is figuring out how much energy it takes to get from negative 15 to 0. Because is this, guys, is this water down here, or is this ice? It's ice. Ice's specific heat is 2.03 joules per gram degree Celsius. So to figure out the Q for the ice, it's going to be 550 grams times, and what's the temperature change going to be?
45. Oh, 15.
No. 15.
But, and then you had to do 2.0. Okay. So,
don't even crunch anything yet, guys. Let's make sure we've got everything accounted for first.
okay, now why did you break it down like that, though? Why do you have to do 2 steps?
Okay, great question. Is this going to heat the same way as this?
No, but my question is like, why, like on like the first, I don't know, 15 or so, it's always just Q equals M and all that, whatever.
Okay, I know what you're going to ask. Let me just stop right there, guys. Chandler's asking, I think. Are you asking why is it a different kind of problem, Chandler?
I just don't know why there's 2 problems in one.
There's actually going to be 3 in a second.
Oh. Okay, see, now
Why? Okay, well, this is why. All the other problems on here have things ever changed phase. Have things changed from a solid to a liquid or liquid to a gas. No, when you go back and look at these problems, they're all the same phase. When you're only working in the same phase, you only have to deal with that equation. But if I'm taking something from being a solid, if I'm melting it and turning it into a liquid, that's three different changes going on. Does that make sense?
All right. So is that so for each phase you have an equation?
Yes, that's a great way of looking at it. For each phase, you have an equation. Okay. So this is taking care of ice going up to the melting point. Guys, from the heat of fusion lab, anybody remember what's the heat of fusion of ice? Jacob.
134.
Nice. Okay. So the Q involved in melting is 334 joules per gram. How many grams of ice do we have? 550. Is there a temperature change when ice melts? No, there's not. So here's the calculation. If I want to get the energy involved in a melt, I take the heat of fusion, multiply by how much we got, and we're left with joules. Hold on, Miguel. We got one more. Now we've got the Q of heating up water. It's easy stuff, guys. At this point, hopefully you've done some practice and you've seen this equation up there enough that it becomes more of a habit. We now have to do the Q equation for heating up the water. The mass is still the same. The temperature change and the specific heat are going to be different. So in this case, our mass is 550 still. Temperature change is from 0 up to 10. And the specific heat of water, we know is 4.185 joules per gram degree Celsius. Okay.
So those ones are just kind of ones you need to know, then, pretty much.
What's that?
You just need to know those, pretty much, right?
What do you mean, know which ones?
Like how many joules per gram?
To melt the ice.
Well, we've done a lab about it.
That's what I'm
So if
saying.
you guys had
You just
to,
need to
look it
remember
up.
that, right?
But yeah, but otherwise that would have to be given to you. Yeah.
And then the 4.185, that's just, you should know that too.
You should know that now, but I would still give it to you if you needed it.
All right.
Yeah. Okay. So now, guys, we have these three values. We're going to get three energy values. What do we do with them when we get them?
Multiply.
We're looking at how this plus this all add up to the whole change, right? So multiply these things out to get our three values, and then we just sum them up. Add them all up, and then that's going to be the total energy. So when they look at a substance, they look at, okay, so we take something like gasoline, and if we heat gasoline up to its boiling point, the point where it's going to combust real well with oxygen, then we can heat it up. We know it's going to turn into a vapor. We know what the internal environment of the cylinder has to be, guys. If you start pumping gasoline through the fuel injectors into your pistons in your car, and it doesn't vaporize, it doesn't turn into a gas, it's not going to burn as well. Okay, your gasoline has to be in a vapor gas state for it to ignite and do what it's supposed to do. When you guys shake your propane tank at home, it feels there's a liquid in there. The liquid won't burn as well as the gas will. And so all of that stuff goes into know. We have to know how that works to make sure that our cars work right. Good to go.
Like on the, like for number 19 it says like how much heat is needed to convert 550 grams of ice at negative 15 to 10 Celsius. Would it be just always easiest to automatically make a graph?
I would, because you have to know. Now, if you didn't know when things heated or melted, there's no way you could solve this problem. Like if I asked you the same problem for iron, that'd be cruel. There's no way you could do it because you don't know what temperature iron melts at unless you look it up. You know, does that make sense? This is a question that's kind of a stinker question because it forces you to look at all the parts of that graph with water.
Are those going to be on the test? A lot of those?
I do one of these on the test.
No, I know like one, but not like.
But it won't be a lot. Carly.
Can you like get rid of the what are they called? Like the no? Like the grams and stuff?
Like cancel one?
Yeah, like cancel them so you just have one.
Yeah. If you get rid of these, the grams, you're canceling all you're left with is joules. This grams gets canceled, and then this is degrees Celsius, so that cancels out. You're left with joules.
You're going to get joules every time.
You're going to get joules every time.
So there's no point really.
Oh, so you okay.
You'll always get joules. That's okay though. I mean, it allows you to verify and see that it's going to work. So let's crunch the numbers, guys, and so we can get an answer and move on to the last problem. And maybe Miguel, maybe we're going to get your wish. We're going to use the whole period and practice these today. 550. You guys, I recommend if you have a calculator, guys, do it too, so you can match up with me and other people to see what you get.
Alright, so tell you what we got, or what you want is like, you have to, let's do, yeah.
The bottom two ones, add them together. Each answer.
You add all of them up.
Oh, add them. Okay.
I'm going to add up all three legs. If you guys got a good calculator, you can even use parentheses and do this all in one single calculation.
What? What?
Lambo. We might say QT for Q total.
Hey, bro. Come here, October 30th, yeah. I think it's expensive. Yeah. 40, 120 easy to get.
Really? Yeah, I did.
If you guys do sig figs, you might get 223,500 joules. I'll do the individual breakdown so you guys, if you get a different number, you see where you maybe made a mistake.
I think Carly beat you.
After you get the QT, is that it?
That's the total energy it takes to go here, here, and there.
Or what? Mine are watery. Maybe that could last long. I still haven't played.
Okay, if you guys are doing this step by step, each of these three levels, each of these three numbers, would be your individual values, and then you've got to sum them up. Sum it up.
What do you know?
Okay. The other question, guys, we go over, basically I'll spend some time just giving you the answer, let you guys spend a little time working on it, but it's on the back page and it talks about a 5-gram sample of motor oil burned in a calorimeter. If you have the spark written down, you're going to solve this almost the exact same way. There's a slight little wrinkle difference in there in terms of what you're looking for, but it's the same kind of setup. Motor oil is burned in a calorimeter. The calorimeter contained 720 milliliters of water, initially at 21.4 degrees Celsius. After the oil was burned, the water temperature was measured at 33.9 degrees Celsius. So you're going to be able to find a temperature change. What was the heat of combustion of motor oil in joules per gram? Okay, ready, set, go. Work with the person next to you, see if you guys can come up with a good answer for that one. And I'll be setting up on the board.
Do we turn these ones in with Chinese?
Excuse me? I would put them on there.
No, but we try that one that you want to work on tomorrow. The one paper that you took 1913.
No, you don't need to turn it.
Yeah, that's like a black screen.
Hey guys, please work on the problems.
Now I can just stop the video.
Would it be like prop 26 or something?